Good morning, everybody. Welcome back to lecture number 36. A little change in the syllabus. The change is as follows. If you go to the syllabus, you will notice that we have the power converters. The power converters are we're supposed to start with power converters, but there is a minor change in the syllabus. The change is as follows. We will cover AC transmission lines, then distribution system, then the power converters at the end. I adjusted the number of weeks to reflect that they are 15. So roughly we'll spend a week, the next 3 weeks. And each, maybe we will need additional lecture. We will see how it goes. But the reason I put this before is it's, as you can see, it's independent, but also it's more important. Okay?
And to the final comprehensive?
Most probably, yes. So today's lecture is about what? It's about the transmission lines. So what did we talk about? We talked about module 1, which is introduction to power system, 3-phase. Small model for transmission lines. Then module 2, we talked about electric machines, transformers, magnetic circuits. Module 3, we talked about DC motors. Module 4, we talked about induction. Module 5, we talked about synchronous generator. So today with module 6, we will talk about transmission lines. So I want to provide detailed exposure on transmission lines in modeling, how to model them, as well as to calculate the different parameters, how we get the R of the line, how we get XL of the line. And we evaluate, is this transmission line good for our system or not, by having small voltage regulation and high efficiency. So we will talk today about types of transmission lines, how we construct them, the equivalent circuit for short lines and medium lines in the next week, some analysis and the VR as well as the efficiency. So transmission lines, what do? They carry power from generating plants. What are the generating plants? Made of? Made of what? Synchronous generators, that is correct. So a synchronous generator is usually is driven by some mechanical prime mover. So we put them away from the city for environmental and safety reasons. So we need to transfer this from the faraway synchronous generators to the city. So we really need transmission lines to transfer them. And those lines can be overhead or underground. If they are overhead, we call them lines. If they are underground, we call them cables. Electricity is usually sent over long distance through overhead lines. We don't see them here, but you see them when you travel. This is a typical structure of a transmission line. You can see we have the earth wires, we have cross arm, we have the tower, we have the conductors, we have the spacers, we have insulators, as well as we have the dampers. So the definition of transmission line varies from a system to a system. A system means a country system. And the highest in the kingdom is 380 kilovolts. There is also other used to 30, 132, and 115. So you have to memorize this number. What's the highest voltage? 380.
And I think in Egypt it reaches until 540, something like that, yes.
I don't know about it, but it's possible to have.
We have under the ground transmission lines, or only this time,
As of now, the highest I'm aware of is 380. Maybe there is higher projects in the future they're working, but right now the highest is 380. Correct me if I'm wrong. I could be wrong, but it doesn't matter. Okay. Let's look at how we construct them. We need conductor, insulators, and tower. If it was underground cable, we just need conductor and insulators. We don't need tower. What is the difference? Which one is better? It depends. The one overhead is easier for maintenance, but more expensive in cost, the building, the construction.
maybe more dangerous.
No, it's not more expensive. It's, yeah, you're right. It is more dangerous. They are exposed to the public, but they are not more expensive. I apologize. The underground is more expensive to build, but cheaper to maintain. So this is more expensive to maintain, cheaper to maintain, more expensive to build because you have to dig, relatively cheaper to build. Okay? The three-phase conductors carry the current, and what is the purpose of an insulator? Two. They provide support and electrical isolation, two purposes. If you look at the insulators, they provide support and they insulate those two cables from having an arc flash, for example. Tower holds the insulators and conductors, and it is firmly grounded with a special foundation and optional shield and ground conductors up to protect against the lighting. The earth wire, they protect against lightning, the bark. This is another view of transmission line. We have the shield conductors. We have the bundled conductors. There are 4 conductors, 1, 2, 3, 4. And they are by spacers. Spacers are holding them. Tower and insulator, and we have grounding rod, as well as we have the foundation. Okay? So these are some of the tower shapes that we see, H frame, etc.
كلها يوز الحين ولا؟
Yes,
بعضها قديمة.
it depends on the civil engineers who design it.
كلها هاي transmission ولا في منها distribution؟
I think they are distribution. 500 kV, 500 kV, 500 kV, 500 kV, 230 kV, 230 kV, 230, 150, 150. All transmission. So what are the conditions, or what do we want from a voltage or transmission line? So let's draw something on the board. So we have ascending and receiving. Okay, we cannot draw green because the camera is not clear. We have sending, we have receiving, and then we have the line. You have here what we call VS phasor, which is a magnitude and an angle. I'm going to call it theta. S. And an angle of theta VS. And we have a receiving theta VR. You agree with me? Your goal when you build a transmission line is to have Vs very close to Vr and I line 3R line is small. Basically, do not overheat the line because we don't want to melt it. So our goal is to have Vs close to Vr. In magnitude, I don't care about angles. Magnitude of Vs close to Vr and the 3I line, where I line is the current here, is minimized. 3I line square, I line square R, which is the losses in transmission line.
هل فيه رينج معين للسموك؟
No, that's generic.
يعني مثلا تحت 50 واط ولا؟
No. The watt is lambda.
مثال
50 watt is lambda, transmission line. No. You have something in megawatt, maybe 1 megawatt.
بالترانسميشن يعني لوسز
Hmm?
يعني هذه لوسز اللي تقول عليها ميجا واط ولا المفروض ار لاين تكون صغيره مره ولا
Yes, but across the line, the losses will be in megawatt, 1 mega.
لاين كبير يعني
The line will transfer 100 mega bar.
اوكي كيف ننقل باور كفايه اذا اللاين صغيره؟
It's, yeah, because the voltage is huge. Okay? So, there is equations that I want you to memorize, not memorize. S for the sending line, complex power that we send, is a 3 Vs I line conjugate. Or you can call it 3 Vs I send. So I send equal to I receive equal to I line. Initial. So this complex power, if you make the current smaller and you make the voltage high, you will still transfer current. What are the lengths of the line that we're dealing with? We have short, medium, and long. Short is less than 80 kilometer. Medium is between 80 and 250. Long is more than 250.
هذه ستاندرد.
Yes, standard. Memorized, okay? We will be in this class solving problems for the short and medium. If you want to solve problems in long, you have to take senior level courses. There are some parameters or definitions. We have the line resistance per unit length. What's the unit of that? Ohm per kilometer. So R has a unit of ohm per kilometer. L has a unit of Henry per kilometer. And C has a unit of Farad per kilometer. Not only that, we have the phase voltage for sending and receiving. Are they line to line or phase? Let's say Y connected, 3 phase. So VR and VS are phase quantities. So you need to divide, we love line to line, you need to divide by square root of 3 to get the phase quantities. And IR and IS are line currents, which are equivalent to phase currents if we connect it to Y. Let's say it's Y connected. The last of quantities is the complex power, or the apparent power if you take the magnitude value, at the receiving end and the sending end. Okay? The ugly truth is they are not equal. Why? Because we have some losses here.
But close to each other.
Yes. Now here the math would play a huge role. We will solve examples later, but for now, do not assume that they are equal. But what is equal is the complex power that's leaving S is equal, the reactive power Q that goes here is equal to the reactive power that is received, but the real power is not the same. So the complex power is not the same. May I repeat it? The S that moves from here to here does not equal to the S that moves from here to here, complex power. Because the P that goes here is dissipated through heat. But the Q that goes from here to here always equal to the Q that goes from here to here. We'll explain it later, not important. So the short transmission lines. Capacitance of short lines is very small. It is ignored in short lines without much error, and the equivalent circuit is shown as the following. We have a sending end, receiving end. We model the sending end with a voltage source, and we model the receiving end with a load, a box load. We model the transmission line with R and J, X. Don't forget the J, okay, please. So where Z equal to R plus JX, R is the little r, which is the resistance per length, times the length. X is omega L times the length, where omega is 2 pi 60. L is the length of the line in kilometers, sometimes they provide it in miles. Have to be careful. So this is the same slide, it repeats the same information. And if you take VR as the reference, why I take it as a reference? It means I set theta VR to be 0, means taking it as a reference. If I calculate the complex power, SR equal 3 VR IR conjugate, if I want to calculate an I, I'll take the conjugate here, I'll take the conjugate here, conjugate with the conjugate, it will be blown away. This R conjugate over 3 VR conjugate. But SR conjugate is a complex number, 3 VR. We remove the conjugate in VR because VR has theta VR is 0. If you take the conjugate of the 0 angle, that doesn't matter. That's why there is no conjugate. Clear? The sending voltage is VR plus I times Z, Ohm's law. And the current is equal, IS equal to I equal to IR. How do we represent them? We represent them by what we call them the two-port network. Who remembers the two-port network? Do you remember the two-port network?
Yes.
What is the story behind? Which course? 13. In the two-port network, we have voltage and current enter, voltage and current leaves. And this network will govern the relationship between the input voltage and the with the output voltage and the output current. Do you remember the matrices? If I write this to be a vector of Vs and Is equal to some matrix called A, B, C, D, if I multiply them by Vr and Ir, I can write Vs to be AVR plus BIR and Is to be AVR, no, D or CVR plus DIR. Now, what was the original equation? We had Vs equal VR plus ZIR. So what is the A? 1. What is the B? Z. And I said Is equal to CVR plus DIR. So we all know that Is equal to IR in this model. So what is the C? 0. What is the D? 1. So that's how we got these values. And these are very important because if you write a software code between transmission lines, you use these matrices for every 2 nodes of the lines. And then you can make the matrix size high or small or do calculation, addition, subtraction using matrices. So is the 2-port network clear? Additional stuff. What is the voltage regulation? V no load minus V full load over V full load times 100. Well, if I don't have any load, I have IL equals 0, صح? Line, which is equal to Is, which is equal to IR. So this implies that Vs equal to VR. You agree with me? So at no load, you're seeing the VR from the R end. يعني احنا نشوف الvoltage regulation at the load. At the terminal. So V no load is actually Vs. Vs over A, where A is 1. And V full load is VR over VR. Because V full load, if you have full load means rated. At rated condition, this is VR. So this is the VR equation. So you need to memorize it. For short transmission line, it's Vs minus VR over VR. How about the efficiency? You get every power. P of S is 3 Vs Is cosine theta S. What is cosine theta S? Is. What is theta of S? Is theta of Vs minus theta of Is. What is theta R? Is theta of VR, which is 0. But because it's the reference, minus the theta of IR. If you divide the two quantities PR over PS, you get the efficiency of the line. Let's do this example by hand. The calculator.
Always VR who be out.
Yeah, receiving end. So a 60 hertz, 3-phase, 50-kilometer line. So we have source. The length of the line is 50 kilometer, and then we have a load. What is VR? He is telling you load at 69 kV. We love line to line, صح? So we're drawing single phase circuit equivalent. So we have to draw per phase, so 69 kilo divided by square root of 3 angle 0 degrees.
No.
It's kilos. Now, I have I line.
ليش قلنا الانجل زيرو؟
The VR always the reference.
اي اوكي.
So what is Z? 50 kilometer times R little r 0.11 plus J times 1.11 times 10 to minus 3 times omega, which is 2 pi 60. So let's calculate it. Calculators? It's 50 times, don't multiply by 1,000. The unit of R is per kilometer. Okay? 0.11 plus J times 1.11 milli times 2 pi times 60. So it is 5.5 plus J 20.9 ohm. So this is R, this is L. So now we can see. Yeah, don't forget the millihenry trick. So we calculated every parameter. He wants to calculate the sending and end voltage. So let's first get IR. So I line equal to IR equal to IS. So what is IR? Is PR over 3 VR cosine theta, which is what? 20 mega 10 to the power 6 over 3 times 69k divided by square root of 3 times the power factor, which is 0.8 lagging. So lagging, we'll identify the angle later.
It's 56.
Wrong. It's 209.184. Yeah, you're right. So what is theta? Plus, because it's lagging, cosine inverse of 0.8, which is 36.87.
والزد اللي هي حقت اللاين يعني ولا؟
Yes. Z is R plus JL. JX. This is not L. This is X reactance. So what is theta of I? Theta of R, IR, is theta of VR minus theta, which is minus 36.87. So what is IR? Is 209.18 angle minus 36.87 amps. Then what do we get? We should get VS equal VR plus IR times Z, which is 69 kilo divided by square root of 3 angle 0 plus 209.18 angle minus 36.87 times the Z, which is 5.5 plus J 20.9. Let's do the math. 69 kilo divided by square root of 3 plus 209.18 angle minus 36.87 times 5.5 plus j times 20. I think I got it wrong. Let's do it. 69 kilo divided by square root plus 209.18 and minus. So it is 43471 angle 3.7 volts. So what is VS line to line? Is 43471 angle 3.7 times square root of 3 angle 30. You agree with me?
Yes.
So answer times square root of 3 angle 30. It's 75.294 angle 33.7 kilovolts. We love line to line. IS equal to IR. So no need to write it down. So, we calculated the sending end voltage and current. Now let's calculate the VR. What is the equation of the VR?
No load minus full load. And full load.
Yeah, which is volt rate. I'm not gonna put it VR, not to confuse with the VR. It's VS minus VR over VR times 100. What is VS? You can get the line to line quantities, or you can get the phase. I'm gonna get the phase. 43,471 minus 39,837 اللي هي 69 over 6 divided by 39,837. What's the VR? 43471 minus 39,837 divided by 39,837.
9.12.
9.12. We've calculated the voltage regulation. What else we need to calculate? Transmission line efficiency. So we already have PR, right? So I just need to calculate PS. Efficiency is PS over PR. No, it's PR over PS. It's PR
Yes.
over PS. PR is given in the problem. PS is what? 3 VS IS cosine of theta S. What is 3 known? VS known. IS known. Theta S is theta of VS minus theta of IS. But theta of VS is 3.7 from the previous part, VS. Minus, what is theta of IS? Theta of IS is theta of IR. Because IS equal to IR, you agree with me?
Yes.
So what was it? It was minus 36.87, right? So what's the theta S? calculators. Why don't you do that? Please do the calculator. We don't have time because I have bad news for you.
40.57.
40?
42.
No,
Sorry.
this is 6, not 8. 40.57.
Point so.
So what is P? 3 times 43.471 kilo. 209.9 times cosine of 40.57. So cosine answer times 3 times 47. It is 20.79 megawatt. So what is eta? Is 20 mega over 20.79 times 100. This is a 96.18% efficient line. Very important to solve this example today. Okay? So this is how to solve these kinds of problems, and the solution is provided here in details. So in the next lecture, we will cover the medium transmission lines. But before that, I'm going to give you the bad news. The bad news is, this Thursday we will have fake quiz, 27. Thursday 4, we will have quiz 5. And then on the 19th, we will have online quiz 6. So it's going to be in the blackboard.
وأقدر نخلي الفيك كوز لحد.
No, the other section, they told me they have a final on 15, so they will not study. And I don't want to provide a quiz if you cannot study.
بس فاين بعد أسبوعين عندنا ميجر يوم 27. 370.
تتكلم في كويس؟
بس.
No, fake quiz, I have to finish this material.
Okay.
So fake it, okay, what's the benefit of the fake quiz?
Follow up material.
The fake quiz is to extra training, to force you to study. Is it waste of time?
No.
It's not waste of time. So you have to attend them. If you don't attend them, you're missing them. Because they teach you. So we'll have a fake quiz on 27, real quiz on 4, real quiz on 19, and then we will finish.
Are they bad news? Are they bad news?
Yes. And then if you do it online, no, I forgot. Yeah, we'll make it online for both sections, to be fair. If you want to cheat, you can cheat. I don't care. If I catch you, 0. 0 in the whole course, the end. Okay? But it will be remote, using the blackboard. You do the honor code. بينك وبين ربك. If you get caught cheating, and it's very easy. I'm gonna have the one who's grading. It will not be easy. No tolerance. Okay, please. We make it online so that you don't have to waste time the day before the final. And I want you to study for the final. So this is the mini final. The mini final where?
19.
On the 19th. Just quiz 6. All quizzes will be calculated.
والفاينل 20 يعني.
I think so.
عندي دكتور الكوز يكون مثلا تايب الانسر ولا نصور الحاضر كيف؟
No, you saw it on paper and take photos. It's okay. I don't know. I haven't written it yet. Maybe I will put it on Blackboard. I don't know. Maybe it's MCQ. I don't know. But it will be timed, certain time. Okay?
بس لو تعيد تاريخ مرة ثانية.
27 4 19.
fake كويز 27 real كويز 4 mini final 19. You will finish. Project when it's due, same day of the final. Okay? If the project quality is low, you get 1 or 2 out of 5. You lose points. Except Maeli and Ahmed, they can get 3 in the project. Because they will get 2 points by not being absent. Okay?
واللي عنده واحد دكتور.
No.
بارشل.
ما في باشا. Okay? Any other question? Okay. توفيق.
الحمد لله.